So this is second part. It was short, but I tried to make it short. So we are covering this book and chapter 4, right? It was and second part, design by features and feature creation technique, comparison, and then they tried to make a unification. Okay, come back. Youngi, you should check internet connection in second room, second floor next time, because usually the second floor was not good in Wi-Fi.
Okay.
Anyway, can you see my screen again?
Yeah, but we stop by page slide 2.
No, I'm showing my memo jang.
Yeah. I mean,
Is it okay?
we cannot see the after slide 3.
What do you mean by slide 3? I'm showing my memo jang.
네, 근데 저희가 3페이지 이후부터 수업을 못 들었습니다. 인터넷이 끊겨서.
Okay, I can. Okay, go back. But I want to explain this one first. Can you see my memo jang? The
Yes.
cell decomposition? Right.
예, 보입니다.
Fahim explained about cell decomposition in his slide. Well, I'm trying to explain cell decomposition in terms of pixel and voxel. You already know what is pixel?
Yeah.
Pixel is a picture element in a screen, any screen, including your smartphone. And smartphone and notebook screen and TV is all made of picture element called pixel. And that is a two-dimensional picture element. And voxel is a three-dimensional counterpart of pixel. So that cell decomposition is very similar to voxel. Right? So it is used for volume rendering. Volume rendering is famous in medical visualization, something like CT scanning, MRI scanning of internal body. So they are using that kind of volume picture element. Right, return back to my slide set. I was explaining the contents, and then it's the slide first one, right? So design by feature. So it is subdivided into decomposition by machining features. It is already explained by Fahim, right? Volume decomposition is saying. Right? They trying to subtract features, machining features from a raw stock. Raw stock is a base material for machining. So machining features are same as material removed by machining operation. Okay. So they trying to develop a machining plan or scenario. So that is the same as CAPP. CAPP is a short name of computer-aided process planning. As I explained to you before, that between design and machining, there is a process called process planning that converts CAD model into CAM process plan. All right, synthesis by design feature is in reverse way. They are adding features to create design or model. So in the heading of this slide, we are talking about design by features, right? So how can we design a model using features? Two subcategories. First one is a minus model. It's a feature, machining feature decomposition, or volume decomposition, subtracting. The second one is a plus method, synthesis or additive, or similar to 3D printing. 3D printing is different, but I'm trying to explain the concept. We are applying or adding, combining features to create or to design a model. Right? And current commercial systems are applying this method. Right? This is already shown, so we already see that feature subtraction, same as this one, decomposition model, subtracting features from stock, right? So stock S here is a base material. We remove MI step, the milling machine, so that we have a stepped model. And then we are another machining out or subtracting, removing the cylinder by drilling features, and then chamfering, and the other. This is a stock also again to make another step down. Right. This is another slide showing the naming of features coming from Autodesk company. Right. And then design by features. So you need to have a feature library. Library means a collection of books, right? Similar to we need a collection of features, including generic feature definitions, right? So in a computer CAD system, they provide a menu. Each menu, most of the menu is corresponding to one feature. And then you need to have a constraint management. And this one is also covered already in a previous class on parametric modeling. Right? So final one, they are saying that many systems, commercial systems, are combination of procedural and declarative. Well, this is a sample of a feature library or design library. You can see that there are features in both in inch and metric and ornament and sheet metal, and there can be more detailed ones. Also, you can have a YouTube video if you have a time. And then there is a comparison. This one is I copied from previous class. What is the difference between parametric and variational? And they are talking about constraint satisfaction in sequential way or simultaneous way by using equation solver. This is slide coming from previous classes on parametric modeling. Okay. And then procedural method by design by feature. Right. So there is a predefined procedures. Right. Some procedural approach is a unidirectional or propagation, or can be a hierarchy, and then also attachment and assembly. And declarative is they are not solving at the declaration. They just declare post some features, and then finally they are collected at one final sequence. So it should have a constraint. Okay? So constraint is defined also together with the features, so that at the final stage the system is solution was found to make a assembly or design. So it is already covered in the previous classes. And then the comparison between feature creation technique, we have already talked about interactive creation of, they are all usually are talking about one feature creation. And then feature recognition is already covered by 5. It is usually used by reverse engineering, starting from already finished product, and then trying to find out, recognize features. And design by feature, we just covered this idea. So we need a feature library, a set of features, and using different features, combining them or subtracting them, we can create a design. So interactive creation, this is very similar to creating some model. Right? This implementation is not so complicated comparing to the other method. So identify one feature for the application, but it takes time to create one single feature. So something like making one model. And there is no common or general definitions, so you need to have a validation method too. But it is implementable. So feature recognition is already covered. So it is an old technology, but the commercialization is already done. And this is application specific because every feature has own meaning. So meaning coming from the application. And it is rule-based, graph-based, as Fahim explained, and surface-based or face-based. This is a BREP, boundary representation method, or CSG-based, or convex decomposition is already covered. Right? So feature recognition is sample coming from a company called EasyCam. So usually the CAM is for machining rather than design. So once design is done, like as a left-hand side model, CAD model is handed over to CAM machining company or organization or division. Then the machining operation need to recognize features. If the CAD model or reference side is given to them only shape rather without any feature information. That is common to real world, commercial world operation because the company is not the same usually. The design company, the machining company, manufacturing company is separated out. So they usually do not provide full information. They only use a minimum handover so that sometimes, many times, they need to have a feature recognition technology. All right. If you have any question, raise anytime. Okay. So this is not machining feature recognition. This is a face recognition. But feature is feature, right? We are talking about different application area, different set of features. Same as, because it is more common to human day life, I try to show the same idea, same concept used, but the application is different. Right, so this is also already covered by FIME, the convex hull decomposition. You see that in the middle, all the components are already convex hulls, right? And then it is converted into right-hand side. So you see that left-hand side, the original model, top model is decomposed into a set of convex hulls. And then it is manipulated to arrive at the final result in right-hand side. Right, design by feature. It's available in commercial system. And features are important, so we need to have a library. And by using this, we can design faster. And then interaction is important. Right, this may be the almost final. So they trying to creation technique, 3 of them, try to combine to make implementation of commercial systems. One more thing. This is a new technology coming from NX, Siemens. Okay. Actually, this is coming, you can see it in bottom, there is a Synchronos. Synchronos is another small company name. So NX merged small company called Synchronos, so that they now are saying that we are providing history-free modeling and parametric something. So this is same as feature recognition. So as I told you that commercial world, the designer and manufacturer are many times separated out. So they, even though the design is done by history-based and feature-based modeling, so there are history inside the CAD model, but the model information is not handed over to the manufacturers many times. So that manufacturer receives only shape or geometry without any history or feature sequence. So they need to recognize feature again for the machining many times. So here the Siemens are saying that history-free means we don't need to have a history. We just create or recognize history from shape. So they are trying to advertise their system. Right? So it is, I'm saying, related with feature recognition. All right? Any question?
Professor, the history-free software by NX, you said it's new technology, right?
Recent, yeah, relatively new, yes. They are advertising, right?
I mean, which year did that get released?
Probably 4 to 5 years ago already. So you can Googling to find out more information. But I don't have a chance to experience. You can ask to other guys from ICAD laboratory. They may have experience. Youngi, do you know about this one before?
No.
Actually, Ik-jun Kim, he explained about this one for his PhD thesis. So it's several years ago, right? So it's new, relatively new, but not so recent. It's already several years already. Okay. Any other questions? No. Then we can go on to discussion session then.
Yeah.